Hi everyone, and welcome to your first lesson of low-level operations. Today what we're going to be learning about is binary conversion. So by the end of today's lesson, you will hopefully be able to describe what binary numbers are, describe where we use binary numbers, and then convert binary numbers into decimal, also known as denary numbers. So first off, what is binary? Well, the binary number system is a base 2 number system. This means it only has two numbers, which are 0 and 1. The number system that we normally use is the decimal or denary number system, and it has 10 numbers. Now, remember, computers start counting from 0, so 0 to 9 gives us 10 numbers. Now, why is binary used? Well, binary numbers are very useful in electronics and computer systems. Digital electronics can easily work with a sort of on or off system, where on is 1 and off is 0. Oftentimes the 1 is a high voltage, where the 0 is a low voltage or ground. So when it comes to binary to denary conversion, we're going to take a look at how we convert a binary number into a decimal or a denary number. So here you'll see that there's one full example that's been done for you. So the binary number here is 11010110. Now, this binary number is what is known as an 8-bit binary number, and the 8 bits which represent the byte are shown up here. Okay, so 128, 64, 32, 16, 8, 4, 2, and 1. Throughout all of S3 binary and denary conversions, you will have to use these 8 bits of the byte, okay? So for every conversion that you do, your table will always have these placeholders at the top. The first step in converting a binary number into denary is to translate the binary number into your table as shown here. So I've just copied this number into the cells, so 11010110. And the way we convert binary into denary is really straightforward. Anywhere that there is a 1, I add the placeholder number into the sum. So there's a 1 here, so I will add 128 into my final sum. There's this 1 underneath 64, so that goes into my final sum. There's a 0 underneath 32, so I leave that blank. I don't add that into the final sum. And I just carry on adding 16, I skip 8, I add 4, and I add 2, and I skip 1. So that gives us a final sum of 128 plus 64 plus 16 plus 4 plus 2, which gives us a total of 214, and that is our denary number. And that's exactly how we convert binary into denary or decimal numbers. Okay, so it's really straightforward. Now I'm going to walk you through another example. Okay, so I've drawn the table out here for you. So the binary number is 11111001. So what I'm going to do is copy that over. So 11111001. And therefore my sum is, so 128 plus 64, because there's 1 in these boxes, plus 32 plus 16 plus 8. I'm going to skip out the 4 because there's a 0, and the same with the 2, plus 1. And so all that's left to do then is add those numbers together in order to get our denary value. Okay, so that's a total sum of 128 plus 64 plus 32 plus 16 plus 8 plus 1. So 128 plus 64 plus 32 plus 16 plus 8 plus 1, and that will give us a denary value of 249. So the answer to that conversion is 249. Now the way to check that simply is just anywhere that there's a 1, make sure that you've copied over the binary number first correctly into your table, and then anywhere there's a 1 you just add the placeholder above. And I can see there that if I add this sum together I get 249, which is correct. So here's another one. The binary number is 1 0 0 0 0 1 1 1. So because there's a 1 underneath the placeholder, I'm going to say 128. I'm going to skip 64, 32, 16 and 8 because there's zeros. I'm going to add on 4 and a 2 and a 1. So therefore my final sum is 128 plus 4 plus 2 plus 1. And if we add those up, that gives us 128 plus 4, which is 132, plus 2 is 134, plus 1, which is 135. Okay, and again the way to check is just by adding all of these numbers up. So that's binary to denary conversion. On the other hand then, we have denary to binary conversion. So if we want to take a decimal number and convert it into binary, this is what we do. So converting a decimal number to a binary number can be more difficult. It helps if you know the powers of 2. There are 5 steps required. Okay, so step 1 is to first subtract the largest power of 2 possible from the number that you're converting. Now when I refer to the power of 2, that's also the placeholders in the table as shown below. So these are the power of 2 numbers that I'm referring to. Step 2 is to then put a 1 in that place of the binary number. Step 3 then, next you subtract the next biggest power of 2 possible from the remainder and you put a 1 in that position. Step 4 then, you keep repeating the above until there is no remainder left. And then step 5, all the places without a 1 get a 0, because remember we have to have 8 numbers consisting of 1s and 0s in order to create an 8-bit binary number. Okay, so if we have a go here, let's convert the decimal number 27 into binary. So step 1 is to first subtract the largest power of 2 possible from the number that you're converting. Okay, so the question you have to ask yourself, okay, is does 128 go into 27? No, because 128 is too big, so I put a 0. We then move on. Does 64 go into 27? No, so we put a 0. 32? Nope, it's still too big. Now 16 does go into 27, so we put a 1. The reason we put a 1 is because 16 can fit inside 27. We then have to find the remainder. In order to do that, we do 27 minus 16, which gives us a remainder of 11, and 11 is now the number that we're working with. So does 8 go into 11? It does, so we put a 1. That gives us a remainder of 3. Does 4 go into 3? No, it doesn't. Does 2 go into 3? It does, so we put a 1. We're left with a remainder of 1, and therefore 1 goes into 1. And as you can see, we've created our binary number here. Now the simple way to check that, okay, is by simply adding 16 plus 8 plus 2 plus 1, which gives us 27. So therefore, we've successfully converted our decimal number into binary. So if we choose a different decimal number, 150, starting from here again, does 128 go into 150? It does, yes, so therefore we put a 1. If we then find out the remainder, so 150 minus 128 gives us 22, so that's the number we're now working with. Does 64 go into 22? No, because it's too big. Does 32 go into 22? No, because it's too big. 16, however, goes into 22, so we put a 1, and that gives us a remainder of 6. 8 is too big to go into 6, so we put a 0. However, 4 can go into 6, so we put a 1, giving us a remainder of 2. Therefore, we put a 1 in 2, and we don't have any remainder left. So therefore, we've now established that the binary number for the decimal 150 is 10010110, and again you can check that by adding 128 plus 16 plus 4 plus 2, and you should then have 150. So that is now decimal to binary conversion. So what I want you to do is have a look and find the exercise, the task sheet that I added onto Show My Homework notification. So it's called 1B binary representation. You can use this video, and you can also use the introduction to binary notes that I've attached to the Show My Homework notification as well to complete this task. So it's just a list of 25 conversions that you have to do. Okay, so you'll have to write out some binary and decimal numbers showing you're working out in a sum. Okay, so just like what I did in the examples. You can upload your answers as an image to Show My Homework if you're just writing on, in a jotter or on a notepad or anything, or attach the completed document as your submission for the lesson. So you can download the task sheet that I've uploaded. You can download that, edit it with your answers, make sure your name's on it, and then upload it as your submission. Okay. If there's any questions or concerns regarding this work, just add a comment onto the notification, and I'll try my best to help you through it. Okay. But hopefully you'll be able to work through binary to denary conversions, and that is your first lesson finished then for low-level operations in S3. Okay. Good luck.